Dear students, I welcome you all for this refresher course on the robotic practices part. So today we'll learn about the second exercise, circular interpolation programming. So earlier presentation, that is earlier online lecture, we just learned how to do the linear interpolation, and this particular presentation will help us to learn how to do circular interpolation. So without much fanfare, we'll just get into the topic. So the task is program an articulated 6-axis robot to move around a circular path. See, the moment when we talk about circular path, there are certain aspects are there. Some basic concepts we need to understand. So now, let me recall what is a circle. Circle is a loci of point. Okay. So in plural, we just call it as locus. So this is the center. So against a center, we just draw a circle. So now this is going to be the radius, and twice the radius is called as diameter. So like this we go ahead. When you get into a robot programming, how to do means when we go like this, it becomes clockwise. When you go in the opposite direction, it becomes counterclockwise. So this is counterclockwise, here it is clockwise. So whenever we go for any sort of circular motion, so direction comes into picture, then radius or the diameter comes into picture, then the center point comes into picture. Okay, so these all are the basic things what we need to do. Now for example, when we are having something like this, so let me take up a profile like this where there is a square and there is a fillet. Okay, so when you analyze only this particular portion, that is only there is an arc. Now, how to go ahead with this arc? Even that is also called as circular interpolation here. Okay, so with this basic concepts, we'll just dwell into the programming part. So circular interpolation, when we go ahead with, as discussed, there is a circle, there is an arc. So these all are the things which we need to consider for the case of programming. Now we'll start with the arc. Why? Because concept is same, so we'll just start with an arc. So what basically an arc is, we have got a circle with the point C1 as the center and R is the radius value. So here usually in the robot part, we never consider the diameter. Always we are focused on the radius, not on the diameter. Now let us cut this particular circle into 4 quadrants and we'll consider only this particular quadrant. Okay, so this quadrant we'll consider and rest this will discard it. And now how to go ahead with this? So now how to program this particular arc is like this. So now we don't want, as I told you earlier, whenever we go for any circular interpolation, we are not worried about the center. So how to go ahead with this programming is like this. So we'll have the arc. So this is the arc what we have got. So obviously there is a center in the previous, like the previous image. Yes, there is a center, but we are not worried about it. See, even it can come like this. There can be a straight line and only this is the arc and it can get terminated like this. So somewhere A to B is the arc point. Whatever may be the thing, you just divide like this. This P1 is called as SP starting point. Clear? So this P2 is called as PP passing point, and this P3 is called as end point or termination point. Okay, so these all are the three things. So now how the syntax will be means, the syntax will be for the case of arc, it will be like this: MVR. R means arc here. So space. So P1 comma P2 comma P3. So this is how we are supposed to program the robot. So P1 means it is going to be the starting point. So P2 is the passing point and P3 is going to be the end point. So it is very well understood that P2 should be in the mid only. It is supposed to be in the midpoint only. So P1 starting point. So this will be default midpoint. Now P3 will be the end point. So now if it is a mere arc or if it is a profile like this, so I'll just draw a very simple profile. So now let me assume this as a square. So you wanted to have a semicircle. So how the concept can be adopted is the same case. So this is going to be, which are the point? I wanted to how this has start, that is a P1, you can use this. So just erase this properly, I'll draw it. See now, it is not only applicable for arc, even you can use the same case for the drawing the semicircle also. So either points, there are 2 points are there, consider whichever the point you wanted to have. So from here a semicircle comes. So this will be point P1 starting point. So obviously this will be point P3 end point, and here mid should be the P2 passing point. So likewise you can go ahead with that. Now there might be a doubt. How do I get the coordinates? See, coordinates, in order to get coordinates, two methods can be used. So method number one is like this. This is the thing. So you can go to any of the CAD platform, say for example AutoCAD. So declare this particular point, or I'll just do like this. P home. So this is the P home, that is robot point. Robot is going to be in the home. So we know this coordinate is 470, 0. So this is the P home point. What I will do is I will consider this as my UCS. See, I am talking about the case of AutoCAD. When you use AutoCAD, this will be the user coordinate system. So this will be the new datum. So this datum from this point, this coordinates will be there. So from there, what we'll do is we'll measure this particular coordinate, x comma y. Then this you can measure x comma y. Similarly, here you can measure x comma y. So likewise you can get, but usually it is tedious, right? So how to do it in manually? If you have got an CAD platform, yes, you can go ahead. If not, how to go ahead with this calculations manually means, so like this. How means, so this is the arc. So this center point, you know, say C1 point is known. So from here we know the distance of this P3 point and P1 point distance is known. We don't know the midpoint of this particular distance. So this is the coordinate what we seek. Okay. Now let me consider this point as 470, 0. So I hope now you can understand what is this. This is P home point. And we know even this particular thing. Now let us consider this radius, that is radius of 50. Radius of 50. So from here, this point, how much distance it will be? So from here it is 50. Okay. Again from here it is 50. So obviously this coordinate will be 470 plus 50, right? So 520, 50. So this coordinate is known. Okay. See students, I consider the same home point itself. I am just considering this value. So as the radius is 50, we get 50 in either cases. Now, how to get this particular point? So for that, we'll consider a simple trigonometric rule. So now let us draw a triangle. So this is right angled triangle. I am just dividing this into two. Okay. So now let me name this A, B, C and D. So now what happens is such triangles are called as 45, 45, 90 triangle. Okay. So these triangles are called like this. So simple. So we wanted to know this particular part. So there is let us not worry about this hypotenuse. So here we know this is the angle. So opposite by adjacent. Opposite by adjacent means obviously it is going to be the cos for the case of x. So this is the simple case. So how you can use this in our cases? So I wanted to, for this particular P point, I wanted to know the coordinate. So radius, that is r cos theta, radius is 50 and cos theta value is 45 degrees. Okay. So here 50 into cos 45 value is 0.707, right? So 0.707 into 50. When you just multiply, what will be the value? I'll just doing it 50. So the value is 35.355. So approximately this is made into 35.4. Okay. So similarly for the another case also when you do, we'll get. So now x-axis. So here the starting point is 470 plus x-axis 35.4 you can add. So therefore x-axis value will be 505.4. So likewise we can get for the another case also. Okay, so another case we'll just do it. So for the case of x, it is r sine theta, that is 45 degrees, so next is 50. So for this also the same value 707. So henceforth we get the same thing 35.4. So here the coordinate of this particular P2 will be 505.4 comma it will be 35.4. Okay, so this is how we are supposed to do when you don't have AutoCAD or anything. So see, for complex profiles, yes, we can go ahead with, but for such simpler profiles, we need not to break our head. Now, I wanted to have for the circle, next case. So arc we just finished. Now for the sake of circle, how you wanted to do for a circle. So for the circle also it's the same concept, but in a different pattern. So now we'll go ahead with. So for the circle, how to do is the same case, but the command will change. Procedure, everything is same, but the command will change. So how we'll see? See, arc means we know the command is going to be MVR. So MVR, the syntax is P1, comma P2, comma P3. So this is how we do for an arc, right? So P1 is going to be the starting point, SP. So P2 is going to be the passing point, PP, and end point is called as P3. So this is how we just go ahead with. And I told you, when you wanted to draw a semicircle also, it is possible. It is also possible. So this will be P1 and midpoint will be P2 and this will be of P3. So even using this, we can continue with the circle. So this is method 1. So you draw another thing, that is P4 you give. So two semicircles you can combine. So like this also you can do. Or the other cases like this. Okay, P1, P2, P3. Now you might be having a doubt how to go ahead with this particular part. So now you might be having a doubt. So P1, P2, P3. So how do we get a complete circle? It is like this. The command will change. Okay. So the process, everything is same. Only thing is the command will change. How means like this. Okay. So this is the circle. Earlier we used MVR. Clear? So now we'll be using MVC. So MVC is for circle. So the same syntax. P1, comma, P2, comma, P3. So now for C means obviously it's a circle. So R. So earlier case we used MVR. So R represented arc. Clear? So now C represents circle. So P1, so any point. Okay, P1, any point on the circumference. Clear? Circumference. And P2 will be the passing point and P3 will be the diametrically opposite point. So this is very important. Okay, whenever you draw a circle, how the software behind how it will calculate is, so the distance between P1 and P3 will be considered as diameter and half of it will be considered as radius, and obviously that's how it is supposed to go ahead with. Okay, so you need to be very cautious enough, and when compared to arc, where arc we need to use the trigonometric concepts, that is I'll just recall. So x is equal to r cos theta for the case of x-axis, and y-axis it is going to be r sin theta. So these all are the formulas what we use, but absolutely it is going to be easy for the case of circles. How you can go ahead with tangential points like this? See, this is the first circle and this is the second circle. So tangential means you can draw first circle, then you can draw the second circle. So here this point P1 will be common. So likewise we can do waves. Say waves means sinusoidal waves means like this. So two different semicircles. So this is semicircle 1 and this is semicircle 2. So likewise we can do n number of things manually. Even we not to be dependent on the AutoCAD part in order to do this particular tasks. Okay, so with this presentation we'll just close for the programming part with respect to the circular interpolation. So to summarize, two things we saw. One is for the case of arc and other thing is for the circle. So by means of change of command, the activity is going to get changed. Okay. So thank you students. Thank you all.